Okay, welcome back. Today we'll look at chapter 1 in irrigation and drainage engineering, and we'll have a considerable portion of the class devoted to the groups and the selection of the projects. So irrigation engineering is the analysis and design of systems that optimally supply the right amount of water to the soil at the right time to meet the needs of the plant system. And so the irrigation engineer must consider the sources and sinks, the capacity of the soil, the needs of the plant, and the mechanism of delivery. So there are 3 steps in system design and selection. Step 1 is characterize crop water requirements, hydrology, and soils. Step 2 is hydraulic design of alternatives. And step 3 is economic and environmental analysis. Realistically, however, the 3 design steps are the job of the first person who struggles with designing an appropriate system in an area, and then everybody else copies that person for the next 50 years. So I learned some lessons when I was up in Washington State designing irrigation systems. There were 3 new products that were tried out in the 16 months that I was there. There was a new type of dripper, a new type of sprinkler, and a new filter. And for the sprinklers, it was a gear-operated sprinkler, and they were put on an orchard, and they all froze and cracked. 10,000 sprinklers that they had to go out and replace. The new dripper didn't stop flushing, and so the whole top of the vineyard dried out, and they lost all their vines. And then the filter, actually, we weren't responsible for those 2 installations, but we were responsible for this next one. We installed a few disc filters instead of sand filters for a couple farmers. And one of the guy was very nice. We were up at midnight, and he said, "Well, this is enough to make a preacher cuss." That's the only thing he said. But the other guy, he had a reputation for a horrible temper, and he started mentioning guns and things like that because his filter was plugging up like every 2 minutes, so it wasn't the right filter for the job. So I developed this theory of new irrigation systems, which is never be the first person to try a new irrigation technology ever. So that was my theory of innovation. And the reason for that is you just don't know what the problems are, and those are 3 great examples. Many other examples of disasters are out there. So generally the farmers agree with that. They don't want to try anything new either. They just want to try what already worked. So even though the type of irrigation system might be pre-selected, for example, a certain type of sprinkler or a certain type of dripper, there's still alternatives you have to consider. And so actually the most successful and forward-thinking farmers, like this guy's name is Ralph Brogy, and he had 2,000 acres of apples on a hill over the Snake River. That he was pretty much a self-made person. And so he would always have us redesign every system like 3 times because he was always looking for the best alternative. And that's a characteristic of good farmers, is that they'll want you to redesign systems. And in those days, when we used drafting tables, that required an extra week for each redesign. But now, the irrigation companies have programs that'll automatically design systems for them. So anyway, you might want to look up this website on Ralph. He was quite a guy. He started like a village for all of his workers, and quite an amazing person. Okay. Well, but we do have 2 examples in Arizona of a good way to introduce new technology and a bad way to introduce new technology. So this is Howard Wirtz when he was a lot younger. He's now 97 years old. So is his wife. And they live up in Coolidge, Arizona. And he moved to Arizona when he was 4, when his family moved here. And they didn't even have a house, and they started farming cotton in a very hot area too, no air conditioning, like if he's 97 now, it was 1930 or something. But anyway, at one point, Howard decided to try to save water. There was a new technology that some researchers, or maybe a company, were trying to get him to adopt. And so they thought that Arizona would be a good place to adopt the technology. So he adopted subsurface drip irrigation. And and I'm not sure if it was subsurface drip irrigation at the time, it was inline irrigation. And what he did is he conducted small experiments on a small part of his farm where he had like 3,000 acres. But he would first start with an acre, then a couple acres. And there was a lot of little kinks to work out. And he eventually worked all of it out. And he became basically the father of subsurface drip irrigation, because even though he didn't invent it, he made it he commercialized it. And he became known as Dr. Drip, even though that was before he got his honorary doctorate at the U of A for all of his efforts. He was actually a graduate of our department in 1951. So anyway, if you type Howard Wirtz in the computer, there are a lot of articles about him and so on. And a picture of him now. There was an article just came out. But anyway, there are currently 10 million acres under drip irrigation. Much of that is subsurface drip irrigation, and that was commercialized by Howard Wirtz. So he had a huge effect on the agriculture. And he actually developed, in addition, he developed 6 implements that he patented and sold, for installing the drip system below the ground surface and for farming over the top of it and around it. So those drip lines remain in the ground for like 20 years, or they can. I mean, not necessarily that long, but they can. Okay, and then there's a bad example. When I was designing irrigation systems in Washington in the early 80s, that sort of dates me, I guess. There was this irrigation magazine that we got, kind of like a sales magazine, but it had a few articles. And they had this picture of this beautiful cotton ranch. Well, I don't know if you call it beautiful. An impressive cotton ranch in Arizona with 10,000 acres of cotton and 13,000 miles of drip tubing. And it was like the future of irrigation was here. And it was at Paloma Ranch. And anyway, I never heard anything about it after that article until I joined the faculty at the University of Arizona. And I was driving to Yuma. I joined the faculty in like 94 or something, or 92. And I was driving to Yuma and I noticed all these huge rolls of drip tubing along I-8. And I was asking somebody about it, and it turns out that they installed the drip lines along the surface of the ground. And every time they wanted to cultivate or do anything, they had to roll them all up and then roll them back out. And it was just a disaster. So anyway, that's why you didn't hear about it again, because it was a disaster. But that's an example. Actually, they did start with 80 acres. I was reading about it today. And then they went to 10,000, but there just wasn't enough preparation and practice. And that's why I say, just never be the first person to try something new in your area, especially don't experiment with somebody's orchard, where you're actually putting their trees at risk by your new technology. And even if a salesman comes along trying to convince you that this technology is great, which they'll try to do, you just shouldn't listen to them, in my opinion.
Dr. Wallen?
Yes.
I think Marcos may be in the waiting room.
Oh, thank you. Okay. Thanks. Okay, So even though the type of system might be set for a given location and crop, such as this is surface drip irrigation of this cherry orchard. There's still the need to quantify the slopes, pipe friction loss, soil water holding capacity, crop evapotranspiration, and all that leads to the determination of the length of time between irrigation events, the length of each irrigation event, and the number of irrigation zones in the farm and the pipe sizes and layout. Okay, so at this time, we're going to stop and start the class activity where you'll form groups of 4 with whom you'll work with on your class project. And if you know somebody who isn't here, who is going to be in your group, you can just assume they'll be here. Otherwise, the people that aren't here will be with all the other people that don't come to class, which is kind of appropriate because then you won't be saddled with they're not coming to class. Okay, so as I said last time, there are 3 types of sensor ET projects. There's website development, and there's, well, I have 3 locations for a section design, an irrigation infrastructure design. So go ahead and form your groups, and then when you turn in your group, the people in your group, then I'll take roll off of that. Okay, and then one other thing, because I forgot to make the quiz visible, I was able to add some more questions because nobody started the quiz. And so what I'd like you to do in your groups today, and this is all probably going to take about half an hour, discuss one appropriate technology and one poorly developed technology that you know about, and discuss how your group might avoid similar pitfalls. And I'd like you to write on your computer or on a piece of paper and then take a picture and turn that into the assignment box by Friday. And then the second thing I'd like you to do is write down your project title, a brief description of the group project, and your personal project. So you'll have your personal part of it. That's more undefined with those sensor projects. With the infrastructure project, the categories are defined. And then write down what your task is during the first phase, which is due in 4 weeks. And then make a definition of your personal tasks overall and a rough estimate of the time required for your part of the project. So I'll turn off the recording now and let you form your groups. So let's talk about the history of irrigation. The first irrigation system that we know about is in Jericho, and that's one of the hottest and driest locations on Earth, near the Dead Sea in the Jordan Valley. However, the ancient Natufians diverted a copious spring and watered their crops with it. And it was during a period of drought and population growth. So there was reduced natural vegetation, and even some of the areas that they planted with rain-fed agriculture, even with that, they didn't have enough food. So they needed to find a way to augment their food supply. And so there was this spring down in the Jordan Valley that provided enough water to irrigate crops. And then the next phase of irrigation was in Sumeria, where the Mesopotamians were able to divert the Tigris and Euphrates rivers, because actually the level of the rivers in that very level plain is higher than the surrounding plain. So they were able to just make breaks in the wall and divert water to their crops in that way. And so again, they were able to divert water by gravity. When you have rivers that are below the ground surface, it's really not worth the effort to lift the water up to the crops. At least in general, that hasn't been done other than with pumps. And this is a translated cuneiform tablet from Mesopotamia. called the Sumerian Farmer's Almanac. And you can read this later, but what you can see is that the farmers had very detailed procedures for growing crops. And one thing I'd like to point out is the end of the quote. They were concerned with a 10% extra yield with proper irrigation procedures. And I think this is a good effect of the effect of efficient irrigation practices. The next great irrigation work, actually probably the greatest, was along the Nile. And unlike Mesopotamia, the Nile predictably floods for about a month or two, I think, at least it used to before the Aswan Dam. And it basically naturally irrigates all the fields. And because there's always extra water supplied to the soil, they've never had a salinity problem there. So what they do is they let the natural flooding occur in the fall, and then they plant winter wheat after that. And the amount of water in the soil is sufficient for the winter wheat for the whole crop cycle. And then, as with Mesopotamia and Egypt, a great civilization developed in China, the Yellow River civilization. And in that case, they figured out how to control the terrible flooding on the Yellow River. And they also figured out how to divert water to fields. And so they were able to grow enough food for their civilization there. And then this is the Wadi Marib Dam in Yemen, where they supported 50,000 people in the Marib Plain in the ancient Middle East. And then any discussion of the history of irrigation wouldn't be complete without Orton Engelhart, who invented the impact sprinkler, which Rainbird bought the rights to from him. So this is the patent on the Rainbird sprinkler. Okay, let's move on to American water resources. So in America, as you probably know, the country is divided in two halves, where the Western United States, except maybe the West Coast here of Washington and Oregon, is arid, and the eastern half of the United States is generally humid. So in the past, swamps or badlands, which is what they called them, were considered useless, and the goal of the US government was to drain all swamps and convert the land to farms. And so they encouraged people to build levees along rivers, and they established the Swamp Acts in 1849, 1850, and 1860. And the basic procedure was that anybody who drained swamps was given the land, whether states or private individuals. So then, after most of the wetlands, which we now consider valuable, were drained, scientists realized that they play a valuable part in our ecosystem. And so they completely reversed course and changed the policy from encouraging people to drain wetlands to protecting even the smallest puddle on a farm, which you basically can't drain. So in addition to drainage, irrigation expanded the population in the Western United States. And so, and actually around the world, the mass starvation, which occurred earlier in this century, was pretty much alleviated in India by the development of irrigation, improved plant varieties, and fertilization. And likewise in the Western United States, large irrigation projects enabled many people to live in the West. So this is the Colorado River, and it supplies water for 3.5 million acres of cropland, which supplies food for 25 million people. Unfortunately, it was allocated to different states in Mexico based on a hydrologic study that was conducted during a wet period. So it's over allocated, and that's been exacerbated by climate change, which is expected to decrease the annual rainfall in the Colorado River watershed and also increases evaporation. So Lake Mead, which is here, had very low water levels this last year. And so many farmers in central Arizona were cut off from Colorado River water and basically only had half their water supply, which came from groundwater. So about half the water in Arizona comes from groundwater, and that was overutilized. And then the state and the farmers, businesses, and mines realized that they needed to do something. So in one of the great examples in water resource conservation, they all agreed to limit future development, and they established these active management areas where they tried to have sustainability, which means they maintain the current water supply for 100 years. That's the definition of it, but it basically means in perpetuity. And this is where our annual water supply comes from in Arizona. We get 2.58 million acre feet per year from the Colorado River, 3.5 million acre feet from groundwater. The Salt River supplies 0.9 million acre feet, and the Gila River supplies 0.3 million acre feet. Okay, let's move on to irrigation system types. And so there's several types of each of three. There's another which I didn't include here, irrigation with drainage systems, but that's not really used in Arizona. There's surface irrigation, which includes flood, furrow, and border strip. There's sprinkler irrigation, which includes center pivot, aluminum pipes, buried PVC pipes, and others. There's micro irrigation, which includes drip inline tubing, subsurface drip, and gravity drip emitters, and mini and micro sprinklers. And you might be interested in this NRCS irrigation guide. Much of the information in this entire textbook is from the NRCS, but they've produced some excellent materials, and this is the link to the irrigation guide produced by NRCS. And here's a map produced by NRCS, which shows the types of irrigation systems in each state. And as you can see here, in brown represents surface irrigation. 93%, and this was back in 1997, so things have changed since then. But 93% of our irrigation is conducted by surface irrigation, and only 7% by pressurized irrigation, which mostly is subsurface drip and center pivots. And then you can see the distribution of irrigation in the other states as well. Okay, so let's go through each type of irrigation system. This is a center pivot where you have a steel pipeline that's transported across the field by carts with tractor wheels. And then in the central United States, where it's more humid, the sprinklers are on top. But in Arizona, this is not feasible since so much water would evaporate, so they have drop tubes. And this is a close cousin of center pivot irrigation. It's called linear move irrigation, where instead of going around in a circle, the pipeline moves across the field linearly, and then they pump out of a canal. One of the disadvantages of this might be that you could lose prime because the pump is up above the water level of the canal. And this is turf sprinkler irrigation, and you might not realize it, but I think 50 million acres in the US is covered by turf. So it's a very important economic irrigation type. This is these are wheel lines and hand lines, and what they do with these is they move them maybe once per day. This is an alfalfa field, and the way that they move it is they have a lawnmower engine, basically, that it turns the whole pipeline, and then they'll move it like 40 or 60 feet to the next position and then irrigate the next day at the next position. These are hand lines where they also might move them daily, or they might set them up during germination and water the whole field as the seeds are germinating. This is inline drip irrigation tubing, and you can see the little hole here. There's holes, let's say every 30 inch, every 12 inches or 18 inches, depending on the soil type. And this is actually for landscape irrigation, so it's on the surface. But what they do with subsurface drip irrigation is they'll put them under the bed, maybe 6 to 8 inches down. And this tubing is hard or forms a circle. Normally with the subsurface drip irrigation, it's thinner tubing and it lays flat when it's not irrigating. And here we have drip tubing on a vineyard trellis. So it's suspended by the wire. And so this is a very common type of irrigation system for vineyards. Okay, let's move on to flood irrigation. And I'm only showing one type here, but generally they'll take the water out of a canal or a header pipe, and they'll divert water into the furrows and just let the water flow by gravity to the end of the furrow. We'll see you next time.